Alright, hi guys, my name is Castro, and as I just told you, this is a really broad presentation about just innovations throughout history that have really impacted society, and they were made possible by chemical engineering. So, so chemical engineering made these things possible either by creating the actual innovation or by making the process just like industrial size and mass production and making it accessible to all of society. So the first thing I'm talking about today is the first chemical plant, which was built in 1790. It was created by Nicolas Leblanc. He was a French surgeon and chemist, and he was working for the Duke of Orleans, and that is how he got access to the capital and the lab in which he ran all his tests. And his main motivation was the French Association of Chemical Engineering said that they would offer a money prize for the first person who was able to create soda ash from regular sea salt. So soda ash in general, it's just used to make a lot of household products such as glass, paint, paper, and a lot of just consumer goods products. And initially soda ash was made by extracting it from wood or seaweed ash, which was fine, but it was a very tedious process and it was very expensive. So Nicolas Leblanc in 1790 mixed soda ash with sulfuric acid and burned it with really high temperature and was able to create a mixture that was really easy to separate. So the creation of soda ash became really accessible. So this was made during the beginning of the French Revolution. So the government felt that this would really increase production and stimulate the economy. So Napoleon coerced Leblanc into revealing the process he used to create the soda ash. And so many competing companies emerged around that area. And it became a booming chemical industry. And it was really the beginning of the chemical industry in general. So it had huge impact on society, not only in that consumer goods such as paper, glass, and soap were being sold very cheaply, since now they were being mass produced, but it was also the first industrial process that had a huge negative effect on the environment. So it led to the first air pollution regulation, which was the Alkali Act of 1863, which just regulated the amount of hydrogen chlorine that was released from the plants. So the second innovation I'm going to talk about is the Haber-Bosch process. It started in 1905. So just in general, a little background: plant growth or just agriculture, it requires nitrogen, carbon, and oxygen. Carbon and oxygen are very accessible since they are found in soil and in water. But even though 70% of the air is nitrogen, that nitrogen cannot be used by plants. So Fritz Haber in the United Kingdom developed the first practical process of synthesizing ammonia from nitrogen in a very small scale. So he presented that in several different conventions, and a German chemical company bought the process and hired Carl Bosch to scale up the process and make it a mass production. So Bosch actually had to convert the entire process, and he had to build his own compressors, his own catalyst. He pretty much changed the entire thing in order to make it be able for mass production. So it took him 8 years, and in 1913, the German plants started running using this process. And This process actually had a huge impact on society. It was the first industrial-scale continuous flow high-pressure process. Previously to that, high-pressure processes were very, very dangerous, and they tended to eventually explode or lead to some kind of disaster. So the fact that they were able to work with high pressure under the safe environment was a very good thing. It was also the first process that successfully produced synthetic ammonia, and it is estimated that thanks to synthetic ammonia in general, 1/3 of the world's food today can be attributed to that, which is very important due to like the huge population growth and all that. The third innovation I'm going to talk about today is penicillin, which was the first antibiotic, and it was created in 1942. So the potential of penicillin was discovered in 1928 when a scientist who was observing the penicillin, which is a mold, was running experiments and noticed that this mold would kill off virus. So he ran some experiments and didn't really get anywhere. And then in 1935, Florey, who was the chemist, he read the paper that was published by the first scientist who discovered it and began testing on animals. He actually began testing on rats, and he noticed that the rats that were not treated and had the specific virus died within 18 hours. And the ones that were being treated with the penicillin would last as long as they were giving the treatment. So in 1942, a patient in New Haven, Connecticut was actually given penicillin for the first time. Penicillin by then was still very experimental, so it wasn't widely used by patients, but the patient was in critical condition, and so she was given the penicillin and she actually improved right away. So efforts began to mass produce penicillin. So by 1944, more than 20 American companies were producing penicillin. The very large number is due to the fact that during that time, World War II was going on, and a large portion of U.S. soldiers were dying, not due to the wounds that they had, that had happened to them, but because of infection in the wounds. So the government started offering grants and different advantages to companies if they were willing to start working on the mass production of penicillin. So at first it had a very little yield because of a tough fermentation process, but with the large number of companies that were working on it, they were able to make enough penicillin to send over to the war. And so in 1957, the chemist Sheehan, he was the first person to synthesize penicillin from an amino acid. So after that was created, they were able to mass produce the antibiotic very, very cheaply. So at that point, it became like regular people were able to buy the penicillin, because at first only the people with very, very severe infections or people from the government or the army were given access to it. So yeah, the impact of penicillin was just the fact that it was the first large-scale antibiotic production. So after that, the new antibiotic, they just copied the process that was done here. So overall, I made this presentation just so we could all get a good idea of the impact that chemical engineering has had in just our everyday lives. Any questions? Great, thanks guys.